Okay, so I'm going to do another lecture this week with regards to kind of messing with this stuff in Unity. So you get to watch me sort of struggle through this stuff along with you guys. So I'm going to just generally pull up Unity here and create a little project. New project. Let's call it randos. Random terrain. And let me put this somewhere. Great. And what we're going to try to do here is generate this terrain. Oh. That's no good. What is going on? Perhaps we can do a new. Maybe I should put it somewhere else. Terrain and create. Cool. There's probably some kind of file collision, something or other. And what we're going to try to do is just kind of create a little terrain and show how you can connect to it with code. Nothing too sophisticated, and I think that's going to be pretty easy to do. So once this project pops up here, great. Unable to update the following assemblies. Editor advertisements.dll. Am I still able to play? Great. So let me put this over here. Notice that every time you use Unity, it's going to completely change your project view and all that crap, so great. So first thing first, let's put into our hierarchy a terrain object. Great. It's pretty big, which is not necessary. So let's go and change it a little bit to a more nominal 100 by 100. And then let's put this at 50, negative 50, negative 50. So right in the middle, allegedly. Cool. And now, once we have that, we can add a script to this terrain. Let me unclick it. New script. And let's call this terrain height. And let's open it up in Visual Studio. Right. And now we've got this terrain height that's connected to it. And what we can do is we can create a private variable called the terrain. It's a terrain data file type. The terrain data is an internal component to the terrain object, and we're going to be manipulating that to do whatever we want. We can do it honestly kind of wherever we want. And first, we want to capture it, so we want to do, let's get it, terrain data. It's going to our game object, which is us, get component, and it's going to be in the terrain collider, the terrain data. So this is sort of an arbitrary thing to remember, but all you need to know is that the terrain data has a terrain collider. And inside of that is the terrain data. And you do this inside of start. Great. So what we want to do is we'll create a little public variable, vector 3. We'll call this the world size. New vector 3 50, 200. So kind of similar to what we had already. I'm not going to mess with it too much. And then we're going to set the terrain data size to our world size. Great. And now you'll notice I have it set to 200. But when I play, in theory, it should go to 200, as you can see in the settings here. Cool. Great. So now you can see already Start is applying its changes to my code, which is pretty nice. So let's now change the resolution of the height map. So another thing we want to do is we can say this as public int resolution, which is not what I would recommend doing that way, and then we can do the height map resolution equal to our resolution. You'll notice, like here, if we collapse this down, you can now change this as well. So when you hit play, it'll, we can actually change this. Well, it won't rerun, so. Anyways. Great. Mesh resolution. So all this stuff you can change programmatically, which is fun. Great. So now let's kind of mess with the actual height array. Let's put this float. This is a 2 array, like a double array. It's going to be equal to new float our resolution and our resolution. Cool. And now, oops, I know how to code, I promise. And then we're going to do the final thing, which is terrain data set the heights to 0, 0, and this height array. Cool. And if we run this, it will look exactly the same. Awesome. Okay. So what if we did something kind of different and we went for what's that fast way to do C# double array for loop. There we go. Cool. Now you guys get to watch me be stupid. Oh, it's just like that. That's not. Yeah, let's do a for each. No. 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 Alright. Apparently C# is not as good of a language as they thought. That's fine. Resolution. Whoops. That's what happens when you use Mac too much. Why would you waste that line of code? Great. By the way, maybe this is too small. We'll go up to this resolution here. Great. So now we can create a little kind of equivalent float. We can now set the height array Wait, is this for real? So I'm so used to C++ that I always have to kind of double check. This sort of like number, like comma thing is weird to me. Oh, that's right. It's just one value. So now what we want to do is we want to, we kind of want to take a value, like a height that is related, like it goes 0 to 1. So let's start off with like the I value. And let's cast it. I don't even know if you need to do that anymore in C# because, you know, it's magic. And let's see what we get. We don't get much. Oh no, we do. It's just not very aggressive, which is okay. Let's multiply this by 10. That's 100, because our height, or no, our height's 50, so let's do it by 50. What's going on? Oh, okay. Apparently I'm an idiot. So notice I'm changing the height array here, but I'm not setting it below. I'm setting it above. So if I set it below the for loop, I will prove myself to be an okay programmer. Nope, I am not an okay programmer because all the values are at this height. I think because 50 might be wrong. Let's try it again. There we go. That looks more like what we want. So keep in mind the height array should be between 0 and 1. You make it more. If you might multiply it by 2, for example, you will get stupid shit happening. Right. So it'll clip at 1. Great. And say I want to make it more of a kind of slope, right? If I'm making it this way, then now it's starting, it's going to start at 0 down here, and now you've got a slope that is going down. Over here it's going to be half and half, and there it's going to be 0. So you can kind of see how you can combine these to the proper value. And again, you know, shouldn't be lost on you. At this point, you've kind of got all the stuff that you need to do everything, right? You just have to. You've got now this value. Oops. Right. Let's see what we get. Pretty cool. A little bit of wackadoodle stuff. So how do we make that even more aggressive? We can start to multiply this. fact, let's call it vtile mutile. Oops. Great. And now it's going to tile it by 10. And you get this pretty cool thing. What's even funner is don't do this shit here. Do it in the update, and then you create this guy. And then what you do, this is kind of the fun part. And what will happen? Well, what will happen? What do you guys think will happen? Is anybody there? Nope, nobody's there. But all compilers have to be fixed. Height array does not exist. Oh, well, what do we got to do here? Let's make this private. Okay. Let's see. Oh, hell, man. What the hell, man? Why doesn't my stuff work? There we go. Well, not much is changing. Not much is happening, huh? Well, let's do it way faster then. Why is it not working? I'll tell you why, because we're not using this shit. Where would we put it? We would put it here. Great. Sorry for my expletives. It's been a long weekend. Whoa, that's way too fast now, so let's make it slower. You'll notice a lot of weird stuff going on with the lighting. And that's also because this UV, you can see kind of how the texture is sort of warping. But it's pretty fun, you know? You can kind of see the limitations of the self-shadowing capabilities of Unity, so you have to really kind of keep that in mind. I'm not an expert on that, personally. But yeah, you can do some really fun stuff. You should also try to do even kind of wackier things, like what happens when you what if you do this? should just really, you know, try it out. There's a lot of really fun things you can do. Like, let's do this, and then what will it look like now? Whoa, we get a lot more noise, right? What happens if I subtract it? Cool. What if I, this is a fun one. If I go, let me do this instead, because this is getting a bit annoying. So what if I do, and then I can do val equals val times val times sine. What would that look like? That's still going to be a value between 0 and 1, right? Not really much. Let's try this. You get a kind of wackier looking thing, and then there's a lot of really fun stuff you can do, like even like val to the power of, I don't know, 3.2. Yes, you know, just try it. It's gonna happen. Well, weird things are happening now. That much is clear. We do need to make sure we absolute this, otherwise we are gonna get into trouble like this. You can kind of see this sort of lumpier thing. I don't love this. It's kind of too, I want it to be inverted. Because what I want these sharp crests that are kind of popping out like that. Not really. What if we do this in that case? Let's do it. Let's do this. You can kind of see how, you know, you just kind of mess around and just have a good time with it. Oh, I don't want negative. I want ones. That's what I want. Okay. Oh, right. I'm being stupid. Right. Yeah. So I'm getting now these more very kind of like sharp, you know, things that stick out. It's a lot of fun, right? You can kind of see how, okay, I want that to be a bit more, let me add some resolution here. Let's do this 512, it's not, or even 124. And then I want to add to the value, it's going to be 90% of the previous one. plus, I want this guy. And that's going to give me a little bit of a noisier, a bit more realistic. It's too realistic. I should do it like that. That's too aggressive. I want it more even. That's too little now, so I want it to be more like that. And you can see how you just kind of keep messing with it until it gets to where you want it to be. Notice it's a little bit clunky. I don't like how clunky it is, so I'm just going to keep on multiplying this up. Let's give it a 4K texture, which is a little bit too much, but it's fine. Where's our camera? Our camera's in a bad place here. There we go. Let's go Y. And now, oops. Let's move this camera around. You can kind of see how nice it looks in one of these valleys. It's pretty fun. So yeah, hopefully that kind of gave you guys a bit of a feel for what you can do with this stuff. It's pretty fun. You know, you can just have a lot of fun with this stuff, you know, and notice that when after I run this example, the terrain information is the same as what it was when I stopped. And so you can kind of imagine if you were to expose those values, the tiling values and the time, you could sort of wiggle them around while you're running, and kind of really get to an interesting set of solutions, and then sort of save that. So yeah, give that a shot. And one thing I want to show you guys, or at least I'll try it, I don't really know what will happen. Let's say I put some 3D objects in here. What's going to happen to that ball if I give it let me make it a little bit bigger. And if I give it a rigid body, right? It's falling ever so slowly. But notice, now that ball is getting kind of pushed around, and it's going to be contained in that little area until it'll probably fall off the world when this other crest comes in and nudges it off. So again, this is really trying to demonstrate to you guys the really kind of beautiful simplicity of randomness. Like, a little bit of randomness is now taking this ball, and the ball is naturally, using physics obviously, following the contours of this randomness. And so when I dropped the ball, I couldn't really tell you what was going to happen. I knew that like something like this was going to happen, but I didn't know exactly. You can kind of imagine using this type of effect for making a game that's doing something interesting and fun. Or even adding another layer of randomness. And in fact, you'll find often with Perlin noise generators, you layer them like one on top of the other. And you get some really cool effects. And that article that I brought up in lecture, it has a lot of really good resources on that in particular. So yeah, hope you guys have fun making these things. Yeah, see you later.